I'm Darcy, and I'll be explaining gas chromatography. So this is an inlet where you inject the sample. The sample is then vaporized and goes into a column, and when it's in the column, each component has a different retention time, so it will come out at a different time. So I'm going to be doing a mixture of no, I'm going to be doing a C6 mixture. So you start by doing 2 like 3 liters of ether. I've actually done this before. And then 2 of the C6. This is then into the inlet and start the run. So in the machine there's a mobile phase and a stationary phase, and the mobile phase moves the sample through the column, and the stationary phase is on the inside of the column and is what the components will, like, they'll be caught by the stationary phase. So after running the sample for 6 minutes, we can see that the first peak is due to the ether, which is the reference peak, and this just shows that the machine is working correctly. Then we have 6 peaks. The first peak has the shortest retention time, which means it has the lowest affinity for the column, whereas the one on the right has the highest affinity for the column, so it has the longest retention time. These 2 peaks are really close together, which shows that they have similar structures, which means that they also have similar retention times. So this is a 2-beam UV vis spectrometer, and what that means is inside the electromagnetic beam is split into 2, and one goes through the reference and one goes through the sample. So I'm going to start out, and that's then goes to a detector, and that is then put onto the computer to form a graph. And so I'm going to start by putting sodium hydroxide in both the reference and the sample, and that's just to get a baseline reading. So I'm going to run a baseline. Now I'm going to be running a sample of potassium chromate. So I'm still going to use sodium hydroxide as the reference, making sure I put the lid on so it doesn't evaporate.
Yeah. Slow it. I like that.
And now I'm going to put the potassium chromate into the sample.
What is it called? Actually.
And then I'm going to close the machine and I'm going to start the run. And what this graph shows is, because the potassium chromate is yellow, the wavelength of absorbance should be between 380 and 420, and the absorbance should be between 0.4 and 0.9, which is what we can see on the graph, with the wavelength being between the values on the graph.